All right, well, welcome everybody to the February 2018 Mississippi PowerShell User Group meeting. Tonight we have Josh Duffney presenting application provisioning with DSC and Octopus Deploy. Take it away, Josh.
All right, thank you very much. So I'm going to start this off with a little bit of a story to give some context to why I kind of came up with this solution and why my team's been working on this. So imagine that you're a developer and you've spent an entire month writing a bunch of code that's going to be deployed out as a web service. And you're finally ready to push the button to deploy it to production. But before you can do that, you have to submit a request to have that application provisioned on all of your web boxes across several different environments. So you reluctantly submit the ticket, and you wait, and you wait, and you wait. And usually us on the IT side, we see them pounding on our door, or at least their manager comes pounding on the door. So now let's imagine that you're the sysadmin that receives that request. You immediately grumble at the request a little bit. I usually do. The night before you were woken up to take care of a production outage at 4 a.m., and now you have to deal with this. Some simple IS changes to some 20 boxes. And you might think to yourself, like I did at the very beginning, that, man, all I need for this to go away is a little bit of PowerShell. I could write a little bit of PowerShell with the web application module, and this could be solved. I will never have to deal with this type of request again. But let me ask you a few questions. Who, at the end of writing that script, still has to take that request? You do. And who has to run that automation when you get that request? And the answer is you do. You still have to be involved in that process. So as I searched for the answers for this, and as I iterated through these things with my team, we found out that we could actually relinquish some control if we were to interface it a little bit. And so that's where the subheading of this talk kind of comes into play, is a world where developers get to manage their own configurations. So what I'll do through this talk is I'll lead you through a few of the failures that led to this discovery of being able to shift that balance of responsibility to your user group through more of a self-service model. And then I will talk about the solution and demo the solution that arose from the ashes of all those plentiful failures. So at the very beginning, I not only wanted to use PowerShell to solve this problem, I wanted to use DSC. DSC is something that I've spent a lot of time with, and I've even authored a Pluralsight course on, and so it was just kind of a natural fit. I know that there's a resource out there for web apps. It's relatively simple configuration. It can't be this hard to offload all this work to DSC and have, the infrastructure as code model and all the buzzwords that come along with that. So my very first implementation that fell flat on its face, I refer to as monolithic control. So as a sysadmin, I typically wanted everything centralized. I wanted it in a single Git repository, and there was one giant DSC configuration. Now this DSC configuration had multiple roles that would hit it, so you would run against this monolithic config, and then determining what type of machine you were, you would get different kinds of roles. This fell on its face for a few reasons. One, it was giant, and no one could really contribute to it without affecting every system. So say you wanted to upgrade a web box in pool A, or in the cluster A, it would not only just update and try to run DSC against that one cluster, it would go through and update literally every web box that we hit. So scaling wise, that didn't really pan out so well. The next attempt that I had was to use partial configuration. So if there's anybody that's familiar with DSC in the audience, DSC has this concept of partial configurations where you can break out your configurations into functions more or less like you would in a PowerShell module, but then the LCM gets really congested with how to manage those and like the order of them, and debugging them is really a nightmare. Even Steve Morawski wrote an article on kind of the pitfalls and why partial config is kind of the devil when it comes to DSC. So that led me to the partially confused implementation of DSC, which also failed. And at this point I had to take a step back, and this is where I discovered the problem wasn't the automation, the problem was we were still maintaining it, and the developers are the ones that they're knowledgeable of the applications that are coming down the pipeline and the settings that they need to have. So what we needed to do is give them a medium that they could communicate those, and they're developers, so the natural fit was code. And so that led us to the next discovery, and it's kind of a Bob the Builder approach. So I kind of dubbed this next journey, can we build it? Yes, we can, because we didn't have the buy-in to get any kind of, I guess, C-class suite tools like Chef, Puppet, or Ansible. We're kind of siloed from the infrastructure team as being the DevOps team, so we didn't have the authority really to bring any of those tools in. And so we decided to build something ourselves, and that's what the rest of this talk will be about. So as we went through and kind of thought more about what this framework would look like, we came up with a few requirements that we did too before we started development. And the first was that friendly configuration format. So we knew that our customers were developers, they're very comfortable in code, but what language could they write in that we could read? And the answer that we came up with was JSON. And the JSON is a format that's used by mainly people that work on a Microsoft stack, but it's a Java implementation. But we could easily abstract DSC out into a JSON DSL, making it easier for the developers to contribute to and somewhat easy for us to contribute to, because it's not that hard of a language. It's not PowerShell, which we're all familiar with, but it's not that far of a jump. It's not like we have to go and learn C#. So that's when we came up with that one. The next was simplified execution. We've learned with the other two previous failures that DSC in its native state with a MOF document. So if you're not too familiar with DSC, you write a configuration. That configuration generates this MOF document, and then that MOF document gets pushed or pulled to a server, and it keeps track of the state and configures it. And this was actually very problematic for us because the web applications just needed to do their particular changes, like set an app pool or create a directory. It didn't need to keep track of the entire state of the server. We didn't need to centralize the entire config. So after looking at what the other people in this industry and this space was doing, Chef and Ansible, they used the invoke DSC resource, which is introduced in PowerShell version 5 that allows you to invoke specific resources and methods. So you could say, just invoke this one method and leave the LCM alone. And so what we ended up doing is wrapping PowerShell around that logic to give us something that resembled the plugins that maybe Chef and Ansible would have used in their formats. The next requirement that we had that we wanted was to deploy at our provision at deployment time. So when a new code gets deployed to a web server, we wanted it to be provisioned at deployment time, but right before the code was deployed. And we also wanted it to be self-contained. So we wanted the project that the developers were using to write their code and to deploy their code to the systems to also have the provisioning. It shouldn't be in two places, so we have to match up if the provisioning went out first or if the code went out first. Because if the code went out first, it would shove it in inat pub and set it to the default web app pool. So we can obviously see where those problems come into play, where if we rebooted the full app pool, who knows what applications would be crushed by that restart, because depending on if the provisioning went out the right time, they would or would not be associated with that app pool. And those are all the requirements that we came up with. And to give you an overview of the deployment process now, so we know that we need a friendly format, and that gave us the base of it. So these are developers, and we're trying to do infrastructure as code. So the natural place to put this configuration document was with their source control. So alongside their web deployments and all their C# code and all the other stuff that developers have for web apps or for Windows services, they now have a JSON document that defines the way that their IS settings and that their web boxes are going to be configured. And that all starts in source control. From source control, it moves over into a CI pipeline, typically called a build pipeline. And all that does is it runs a bunch of tests, compiles code, and then generates an artifact. So inside that artifact now is the configuration settings inside code for their IS settings and their Windows Server settings. After that, it would go and deploy through Octopus Deploy is the tool that we use. And that is where we'll be spending the majority of this demo. So at the point the team city builds an artifact, it then pushes it to Octopus, triggers a release to deploy, and then goes ahead and provisions the app pool and then deploys the web code. So that's the high over process that we came up with, and now we'll just dive into some demos. So before I click into any of this and cover what we're going to go into, does anyone have any questions or interjections, I suppose, into the kind of the process and flow or how we came about these requirements and solution? And if not, that's okay. All right. So the first, am I still sharing my screen?
Looks like it must have dropped.
I can't see it.
No.
Okay.
You're not.
I think I might have clicked the little X button. There we go. Back up.
It may take just a okay, it's loading. Okay, I see it now.
Okay, sorry about that. Too many bars. So the first thing that we'll take a look at is the web app config, and you'll get an idea of what the JSON DSL that we wrote looks like. And this is what the developers would actually write to configure their stuff. And this has actually been tremendously useful in thinking about the way that your customers would interact. The extra effort that we put in to make a JSON DSL around PowerShell really helped our developers contribute back. We've actually had 4 instances that I'm aware of now where developers ran into an issue with their provisioning. They debugged it inside of Octopus, went back to their source code, updated it, cut a new release, and deployed it out and fixed their own provisioning issues. So just imagine that. No more ticket about that and back and forth and waiting in a queue. So it's just phenomenal results with that. The next thing we'll talk about in the demo is the Octopus projects themselves. So how the code works and how the actions inside Octopus are actually running PowerShell behind the scenes to provision stuff with DSC. There's a number of projects we'll look at. The first is the web app. So this web app is actually kind of a placeholder for a product team. So we have roughly 40 of these using this template in production now, where developers are writing the code that provisions their own IIS settings. The web app is just a placeholder project for that type of setup. Then we'll look at the step template that actually does this. The step template is something in an Octopus that allows you to bundle PowerShell code together, or C# or F#, and then use it in a repeatable way. So don't get too hung up on the Octopus concepts and stuff like that. It's basically a function stored in Octopus. And then we'll talk about the invoke DSC bootstrap, because there's obviously the chicken and the egg scenarios of what bits need to be on the box for this type of project to work, and we'll talk about that at the end of the demo. And then if time permits, we'll dive more into the PowerShell module invoke DSC. So invoke DSC is what makes this JSON abstraction all possible. It is a PowerShell module that's on the gallery that you can use if you want to abstract out DSC into JSON. To me, I find it actually a little bit easier than the normal DSC resources where you have to write a config, compile them off, and push it. You can literally just invoke those configs. We'll talk about how you can obtain it. Obviously, from the gallery would be one way. And then we'll work on how it works and kind of some of the internal things of invoke DSC. So let me open up my demo. So to start, is the font size okay, or should it be a little bit bigger?
Looks good to me.
Okay. So you can see here, I guess to start off, how many people in the audience are familiar with JSON? Somewhat or not at all? Few people? Good. So it's really, if you've used Azure, you've used some I can spell JSON, that's good. It's really simple. It's a lot of curly braces and double quotes and stuff like that, exactly templates for Azure. So at the very beginning, we have an object called modules. And so the purpose of this is to define, just like we would use in DSC, you would import DSC resource, and then you would then be able to use all of the resources inside that resource module. So these are the modules that this configuration needs. So for this example, it needs 2 modules. It needs the X Web Administration, and specifically version 1.9.0.0. It also needs the C NTFS Access Control, version 1.3.0. And we'll talk about the source that it comes from, so you can either pull these from the PowerShell gallery, or you can pull them from an internal package manager or a package source, like Artifactory. But this array just defines your modules that you want in there. And Invoke DSC will actually dynamically pull those modules down, and they need to be there before DSC executes, otherwise it won't be able to look at the properties of the resource. So that very first object is your modules resource. There's no limit to how many that you can have in there. And then the next object that you'll see is the DSC resources to execute. Inside here lives a bunch of other nested objects, and everything in here are just the resources for DSC. So I guess another pool of question would be, how familiar are people with DSC natively, not even an abstraction? Few people? One person? So this should look very, very similar to you from writing a configuration. So this right here would be your resource name, and that's the arbitrary name that you would give it. It's just something to basically call out your attention to what it's doing. So this is going to be the web app pool folder, or the web app folder rather, and this is an object, and inside that object are all the properties of the DSC resource. So it starts off with the DSC resource name, which is file, and then everything else inside this are the properties of that resource. So you have destination path, which is this weird syntax here, which is a variable replacement in Octopus, which I'll talk about later. It also has a type, which is a directory. So this is going to create a directory, and then I'm also ensuring that it's present. So if it doesn't exist, it'll create it. If I were to set this to absent, it would obviously then remove that file. And you can see that there are several other objects inside this DSC resource to execute. It does do it in a sequential manner, so whatever you list here will be run first. That's how you order it in Invoke DSC. The next one creates a folder for the logs directory. Then it goes on to create the app pool and specify all these settings here. And then it creates a web app. And lastly, it sets some ACLs on the log folder. So all these properties line up with, if you were to use the get DSC resource syntax commandlet and pull those properties in, all these will match up. And since it's JSON, it's got specific types that you can use. So you wouldn't put $true here, you would put true, and that's a Boolean value for that. If it's a string, it's going to require double quotes. And then also, if it's an integer, it will just have to be a number without double quotes. And so that was another benefit for our developers, because they were already familiar with that, and seeing this reaffirm those types for us, or for them, where PowerShell isn't as familiar to them, which is interesting because they're C# developers that worked on Windows for their entire career, but a lot of them surprisingly aren't that familiar with PowerShell and what it can do. So any questions so far on the DSL itself and how it's structured? See, one person typing, and nope. So the main reason for the JSON is that the developers were more familiar with it versus any other, like a YAML or something like that. We found an added benefit later that Octopus also likes to consume JSON and has some built-in features that allow us to transform these variables very easily. So it was kind of a plus that we didn't think about at the beginning, but definitely is the case. Octopus does consume JSON way better than any other format. Cool. So with that, what we'll do is then take a look at what would happen in the CI. So I don't have the CI process set up. We would use TeamCity to compile this, but basically what would happen is the developers would have a directory with this in there, and it would generate a NuGet artifact. So it would look something like this. This is just a NuGet Explorer. If we open up this Octopus would basically, TeamCity would generate a NuGet that would then push to Octopus, and then it would deploy it out to the system. So this is actually the artifact that my Octopus instance is going to deploy down to the web server and then extract. So a NuGet, if you're not familiar with, is very similar to a zip file. It's just a way of archiving, compressing, and putting stuff together. But inside of this, we have this artifact, we have this config inside here, which we just took a look at, and its versions and whatnot. So you can see what version of your configuration went to the box at a certain time. So that's another benefit of putting it with the developer's code, is if there's ever an issue in between versions, you can easily tie it back to the version of the NuGet that was built. And if we double click on this, we'll see the same syntax. So keeping that in mind, the developers have a JSON document that they write to provision their app, and then that gets bundled into a NuGet package, and that NuGet package gets uploaded to Octopus, and at that point it's ready to deploy. And so that's what we're going to look at next. So if we go to my dashboard, inside here a product team would have their Octopus project, which would be web app in this case. And if we go to the process, we can see that the very first step is to deploy that web app NuGet. So that's going to have all their artifacts in there, including their JSON document. And then the next step is going to be to invoke the DSC app config, and that could be easily renamed, and we actually do rename it in our project to provision application or provision web application, depending on the project. And what this does is it uses that step template that I talked about, and it uses two parameters for the step template. One is the path. So in Octopus, you can give it a path of the previous step, and that's what this is doing. It's using the web deploy output package installation directory, and then you can see here that I've hard-coded the web app config name. So that's the direct path of where the NuGet's going to get extracted to, and then it's going to point at that JSON document and then run some code. And then I'm pointing it to the PowerShell gallery because I don't want to set up my own internal. And that is the place, the source, that it's going to obtain the modules from. So that's an important thing to note, that is the repository source where anything specified in that modules object inside the JSON is going to try to obtain those artifacts from. The actual step template for this is rather simple. It tries to import the DSC module. If it can't, it throws an error, creates a hash table for splatting with the path and repository, and then it uses this invoke DSC configuration commandlet. That is obviously part of the invoke DSC module. It's a commandlet inside there that allows you to point at any input object of JSON or JSON document and obtains the modules, and then it wraps around invoke DSC resource to invoke the test and then run the set command. And then at the very end of the process, it would deploy their web app. So I wasn't crafty enough to create a C# application, have it deploy a web app service or anything like that. So it's just going to write output and say deploying web app. So any questions at this point with the way it's laid out and the structure? Now this is very heavy with Octopus, so if you don't use Octopus Deploy, some of the stuff isn't going to make that much sense. But just think of it this way. Octopus is really just the runner of the code. You could easily run all this through TeamCity, or you could run it through Jenkins in the same way, because everything that's underneath is really PowerShell. So just keep that in mind as I walk through it. Okay, so what we'll do next is we'll create a release. So what a developer would do at this point is they've uploaded a new artifact and they want to deploy it. So in Octopus, they have the notion of a release, and that captures all the artifacts for a particular release that's then going to be deployed. So we're going to create 003, and then we're going to deploy to my development environment. So inside Octopus, there's a concept of environment, so you might have to develop stage and prod. If you're like us, we have like 20 more than that environments that people could or could not deploy to. So what it's going to do is going to take that whole project and it's going to deploy to whatever's in development, to the web servers, those three steps that I just outlined for you. So we'll deploy. It's going to say, are you sure? Here's what's going to happen. So I'll click deploy. And this is running up in Azure, so it might take some time. But we'll just kind of wait for it and see how it goes. So right now it's acquiring the NuGet from the server. So the Octopus server actually has version 001 of the web app, and it's going to push that down to the tentacle, which is the web server that it's deploying to. You can see right here it's calling out web 1. So it got that deployed. Now it's doing the variable transforms, which we'll talk about in a second. There's two ways that you can transform the variable. It's worth mentioning here. You can do variable substitution, which is that weird like £, and then the true curly braces with the name of a variable in it, or you can do straight up JSON replacement by parsing through the objects, which we'll look at when this is done. So it looks like it did that, and now it's running the invoke DSC on web 1. So as I mentioned before, As I mentioned before, invoke DSC, it mirrors what DSC would do in the sense of it's going to run the test method first, and then if the test fails, it's going to do the set method. So we can see here that I've already run this before, and these 4 resources, the web folder, the logs folder, the app pool, or these 3 rather, all just tested fine, and there was no changes. But there was a change in the web app, so it then invoked the set. So then it went ahead and did that. This is just a DSC verbose output that I haven't been able to suppress quite yet. And then the start test for the log access, and that just tested fine. It must have already had that. If it didn't have any of these, the test would have failed, and then you would have seen a set after every one of these resources being run. So this should look very familiar if you've ever used DSC and you've put the verbose filter on there, or the verbose parameter, and you see all the output of the config. And then my cheap way of deploying a web app. But that is that. Any questions so far on the DSC, how that plays out? Now again, remember I'm just using Octopus as the runner. You could run and invoke DSC straight on a box or through PowerShell remoting or any of those methods. Looks like we have one question. So clarify if you can, when the JSON is actually converted to DSC, or is it no moff here at all at any point, it seems. So the JSON is converted by a helper function inside invoke DSC, which converts it into a PowerShell object. So there is no moff at all. It strictly converts the JSON to a DSC custom object and then passes that to the invoke DSC resource. So absolutely no LCM modification at all. I actually go ahead and disable the LCM on most of these systems so that there's no conflict. It's very, very similar to how Ansible and Chef both do it. Work if the LCM is in push mode or pull mode all the time. I have not changed any of the LCMs to pull mode, so I can't say to that, but in the push mode it works just fine. I believe the invoke DSC resource doesn't care which state the LCM is as far as push or pull, because it's a separate command that outside the LCM. It basically turns the LCM into an API call at that point. But I have not tested with pull, so that'd be a good thing to try out. Okay, so no questions there. So we'll go ahead and look at the JSON document after the variable replacement, and then we'll take a look at how you can do variable replacement. Because as you move through environments, you might want your config to change based on where it's going. So it might be called, the web pool, for instance, might be called dev web pool and the dev environment and just web pool and prod, just because there's different semantics within different environments. And so variable replacement is very important. I actually have the output of that mapped here. So Octopus, when it deploys through, it maps all of its artifacts back to you. And so this was version 001 of the config, but it was the 3rd release that we created. So that's why you see the _3, and it matches with the 003 above in the deployment. So if we open up this JSON config in VS Code, of course, you'll see the difference. So you just saw, here's this weird variable, and now we see it's a JSON for C web app. And that is called variable substitution in Octopus. So if you look at this right here, that is actually a variable coming from Octopus. So anywhere it sees that # or hashtag, I guess is the new way to call it, and the curly braces with a variable name in it, Octopus is going to go through and replace that with whatever variable is scoped to the project. The other way that you can do that is by actually just pulling down. So we could go DSC resources to execute, @pool, and then name, and we could actually affect this value here without having to do any kind of variable substitution. The benefit to that is the config will run with or without Octopus because there's no hard-coded Octopus variables. But there is a reason why you would want to do both. So that's what the config looks like after it's transformed, but the next question you might have, well, how does it transform? Where do these variables live? And so if you go into the Octopus project itself, there's a variables tab. There's different scopes of variables. I'm only worried about project-specific variables. You can also have variable sets, but I'll kind of leave that out of the discussion. So as you can see, the web app destination path was the one that we were looking at before. And you can see that's why the variable got replaced with C whack web app. Now when you're using variable substitution, remember that you're replacing JSON syntax, so you have to do the double whacks in that case. That's just the way the JSON's written. You can also scope the variables. So this is only going to replace it with this value if the environment being deployed to is development. If that isn't defined, it's just going to apply it wherever. So another one that you saw here was terminate. So this is how you would, without changing the variable inside the config to an Octopus one, you can actually change it by just basically navigating the object path in JSON. So you see DSC resources to execute, @pool, idle timeout action, and then this is the value. So if we were to go to look at the config, we would say DSC resources to execute, web app pool, idle timeout action, terminate. So if we wanted to change that to suspend in production or suspend in dev, we could scope that variable to the different environments and then have it replace it at runtime. And so then when DSC goes to invoke, it's going to invoke that variable transform document. That kind of loses some people. There's a lot of steps in that, so let me know if you have any questions. All right, no questions? So the next thing that I will talk about is the Invoke DSC project itself. So inevitably, there's going to be some chicken and egg scenarios. So like I mentioned, that modules array, or that modules object rather in JSON, it's pulling modules from the PowerShell gallery, but if you've done that on a box for the first time, you know it's going to prompt you for a trusted source. So if you haven't trusted the PowerShell gallery, it's going to prompt you every time you try to obtain an object from it. There's a specific version of package management you need. So there's the chicken and the egg scenario. And so what we came up with is, well, we have this PowerShell module, and we're developing it as code. So why don't we just treat it as a code base and deploy it like our developers deploy their web apps? And that's exactly what we did. We created a CI pipeline in TeamCity that then creates an artifact for that to then deploy out into our environments. And then we just kind of added a few things to it. So this Octopus project actually deploys out a few modules. So these are all PowerShell modules. We do the package management module. We deploy Pester because we also do infrastructure validation, which I'll show you in a second, with our app pools. So after they've deployed, we actually run a Pester test against them to make sure that DSC said what it did. Because if you use DSC at all, sometimes it says it did something and it didn't. And we want to verify that with Pester. The next thing that it does is puts down the invoke DSC module. So when the people run their configurations, they don't have to worry about dynamically trying to obtain invoke DSC. It's already there. And this is kind of a way that we provision an environment. We deploy this automatically to everything. Octopus also needs the WMI max envelope size increase to return all the verbose output from DSC. And then I kind of cheated here and bootstrapped the PowerShell gallery. So if PowerShell isn't trusted, go ahead and set it as trusted. So that way, when it grabs these modules, it's not going to prompt me, are you sure? True, false? Because when you're running it in the background in an automated process, you obviously can't have any manual prompts. So that's what I've done there. Now, the really cool thing about deploying your PowerShell modules through a deployment tool, like a software developer, is you have a lot of access into controlling what's in what environment. So if we go to channels and go to lifecycle, you see these version rules. These version rules lock the version of each of those modules that I just mentioned into a specific version, so that way when you create a release, you cannot go past any of these until you update them. So if I was to increase the version of invoke DSC to 9.3, these two would have to stay the same until I changed these variable set rules. And so that way when you create a release and you deploy it out, you can be very certain about which artifacts you have out in your environment. And if we look at the release, it actually just copies it to the package source and the version. So it'll just replace it. You can have multiple versions if you want, although with package management in general and PowerShell Kit, you don't want multiple versions. It'll cause you a lot of headaches. But any questions so far with invoke DSC deploying it? Looks like we might have one question, so I'll wait. Might be a long question.
If you have a mic and you have a question, feel free to unmute and ask it or type it in the chat.
Oh, absolutely. So this is pretty much it for the talk. Here we go. Could you publish your PS module as an artifactory and then set all machines to use that as a source rather than copying them there? So that is actually where what I'm doing essentially. So if we go to processes and we go to package, I'm pulling the package from PowerShell Gallery as a NuGet, and I'm using a custom install directory to extract that NuGet to that specific version folder. Is that kind of what you're looking for? That question. So you could definitely just change the source of the feed to point to your internal artifactory feed in Octopus, which would be the configuration library probably. Yep. So yeah, so what they're talking about here in Octopus, you can have external feeds. So you can set up, I set up the PowerShell gallery. You could easily set up your internal ones for Artifactory or whatever solution that you have. And then when you go back to the project, sorry for all the clicking, you would just choose that source, that feed source, and it would extract your NuGets. Yep. So that way you're simulating what you would do if you were to publish something to the gallery externally. It'd be kind of the same workflow. But. So let me minimize this and go back to the fancy PowerPoint. Did not mean to start at the beginning. Sorry about that. So at this point, done with the demos. We can go in. I don't know how much time we have left, but we can definitely go into the demos about how to use Invoke DSC. But at this time, I'll open it up for more general questions. Feedback would be great. And what is your name? What is your quest? What is your color from Mighty Ponthai and the Holy Grail? But thanks for listening to me for the past 40-ish minutes.
If you're not using the LCM, how is it being deployed? Just PowerShell remoting?
So Octopus uses the tentacle, so it's all local invoking of the LCM. So everything runs as NT system through the tentacle in Octopus.
And you did a great job. Thank you very much.
Thank you.
Yeah, I want to thank you, Josh, for presenting this. And it looks like as far as timing, you'll be right on for the PowerShell Summit.
Oh, sweet. So, what time do you usually wrap up these? I mean, I could definitely dive into some of the other projects I'm working on with basically, I mirrored Ansible, so I call it Ansible-ish. It's how we do config management, or I can dive into Invoke DSC.
Yeah, we've still got some time. Is there anything in particular that anybody that's here wants to see that Josh just mentioned?
Also, don't be shy on the feedback. Anything and anything helps. And I promise not to be offended. Oh, looks like we got a question. Tentacle is like an agent. Also, can you briefly show how Octopus knows which device to deploy to? In the Ansible-ishness. Sure. So to answer Jake's question about the tentacle, Octopus has the notion of environment. So you can see I have one environment, and inside that environment I have one tentacle. So a tentacle is an agent. It's just like if you were to have a chef agent or anything like that, any kind of agent-based system. It's just installed there, and then it has tags of roles. So that's one thing that I didn't cover, and I should have, so that's a great point. So inside each environment, a machine has to be tagged. It has to belong somewhere. So this actually belongs to development, and then its target roles are web server. So how that comes into play, if we go back to our project, you'll notice how all of these steps apply to web servers. So that's how it's targeting which nodes in development get hit by this project. So Octopus does everything by role-based administration, or role-based deployment. So anything with web server would get this project. Now there could be 3 other machines in the development environment, maybe some SQL boxes, and they would be unaffected by this deployment. Does that help answer the question, Jake? Awesome, cool. So it looks like we wanted to dive a little bit into the Ansible-ish. And let me pull up the GitHub for that. So it helps to look at the overall architecture of roles. So if you're not familiar with Ansible, it has basically like a role-based description in an inventory file. So I'll talk about the inventory file first. Inside here, it's all JSON based. We have this host object. Let me take one step back. So we don't have a config management tool. And as you just saw with the web deployment, I was messing around with some IIS settings. But how do we make sure that that has the web server feature on it? And so this is where I came up with this Ansible-ish way of doing it with Invoke DSC and Octopus Deploy. I basically converted them into a config management tool like Ansible. I call it Ansible-ish because I stole a lot of the concepts from that platform. So with that context, I had to create an inventory file to define an environment. So this is going to be the development environment, and it has a host object, and inside that we have web1, which maps up to our environment inside Octopus. And then in here, we tell it what Octopus environment it's going to go on. So there's automation in the background that keys off this information and bootstraps the tentacle from PowerShell. And then it also adds the role of web server. So this is actually how the web server got built and tagged in Octopus. And then inside that, you actually have roles that for configurations that are JSON of common and common.web. So what will happen is PowerShell will go ahead and create the VM and tag it in Octopus's development, and then it'll do Octopus roles. And then at that point, we have another project inside Octopus, which we'll take a look at in a second, that goes through and invokes all of these roles. So if we go back one layer and we go into the roles folder, you'll see that we have the common.web and the common. And so if we go into these folders, you'll see a configuration document just like the IIS one that we showed at the beginning of this demo. And this one's super simple. It uses the cchoco module, and it installs Chocolatey to cchoco. So that way I can install, VS Code or .NET Core or whatever it may be from Chocolatey. And then on the flip side, this is how the web role gets installed. So if we go inside the web or the common.web.json, you can see that it has several basic Windows features for IIS web servers. It obviously has the web server feature. Its name is web-server, and then I want to ensure that it's present. And then it's doing some other web request monitoring and basic authentication features installed. So that's the code base right here. So all this gets packaged up into a NuGet and then shoved over to Octopus. And at that point, what you would see is this project. So that code base that I showed you is actually a NuGet file called Ansible-ish. And it looks like, oh, my bad. If we go to library, packages, you'll see Ansible-ish, and we can download this NuGet. And if we open it, it's going to look just like that Git repo that I showed you. It's got roles, some scripts to run, which I'll talk about in a second, and then that inventory file. And so if we head back over to Ansible-ish, go to the process. So it deploys it, and right now, since there's only like one node in here, we invoke the playbook for the web servers. So it's going to invoke the playbook, and what matters here is this the target. So it's going to run on the web server. And then when it runs on the web server, it's going to parse the inventory file and find those two roles that was defined, the common and common.web, and then it's going to invoke those. So if we create a release, or we'll just redeploy the previous one. Go here, redeploy version 1. And it's the same concept where it's going to deploy that on that NuGet file. It's going to have an inventory file. It's going to pull that into PowerShell, parse it, grab the roles, and then it's going to invoke those roles. So we'll see that in a second. While we wait for time's sake, we'll take a look at the step template. So there's this invoke playbook. It's a PowerShell script. And let's take this out into VS Code. So what this does is it .sources this playbook, which is actually inside that repo that I showed you, creates a hash table, and then does some include logic. So you can include or exclude roles as you deploy them, and then it just passes it to the playbook. So this playbook looks like, where's my, this. So it's got all those parameters. I'm rushing through this for the sake of time, so if you have questions, feel free to stop me. But you basically give it a path, the host name that you're going to invoke to. So that's where it grabs the Octopus name of the node that's running it. And then from that, it actually determines what the roles are. The repository to pull PowerShell modules from, and then the inventory file name itself, which is, in this case, inventory.json. It tries to import invoke DSC because it needs that to invoke the roles. Grabs the content of the inventory file, and then if the host name is matching the host name that it's running on, it will go through and do this logic. So if there's any exclude, it'll remove roles. If there's any include, it'll do some logic to handle that. But then eventually it gets down here. So all the roles that it defines, it's just going to go through a for each loop and try to invoke those. There's also some logic in here to do like pre and post roles. So like say for instance you needed to install a feature, reboot, and then install some more stuff. You could have a pre-config, have Octopus handle the reboot, and then invoke the next stage of your configs. And then it just uses invoke DSC again to do that type of logic. So let's look at our config. See if it's done. Sweet. So if you come in here, it'll tell you what roles it found. So it found common. The config was at this location. And then you can see that it just did the test. And then it found another one. And this actually had 4 resources in it. In the common web. And then it invoked those. So that's how the Ansible-ish works. In a nutshell. That could be a whole presentation in itself, but that's how we've kind of hacked this module that we wrote, invoke DSC, to basically be a config management tool and an app provisioning solution all in one with custom code. So the moral of the story is, you don't have to buy it, you can build it yourself. It's okay to do that, and it can be a lot of fun while you do it. From the perspective of troubleshooting, debugging issues during this process, I think you said DSC package management is handling the JSON to DSC PowerShell conversion. Is that viewable on the end device at any point to see that conversation working as expected, or is it convention process dynamic? I.e., is there a DSC config on the box at some point? Yes, there is. There's the DSC. All those DSC configs are deployed down to the box. So if there's any issue with your converting to DSC, you could easily remote in, try to run that public function with inside invoke DSC to convert it and see what's wrong with your PowerShell object. That's where the debugging comes into play. There's quite a bit of error handling in there too to handle that, to surface those issues. And we do linting on our JSON documents prior to make sure that there's no conversion issues. Where does Octopus stick them? You determine, or default location. The default location for Octopus is the applications directory that I was showing a little while ago. So if we came in here, so that this is I'm using containers here, so you can actually do this entire lab yourself by pulling this Git repo and doing Docker compose up on a Docker host. So there's a volume mapping for your tentacle, and your tentacle it's usually C applications or C Octopus applications. And then if you go into the environment, you'll see all the projects that have been deployed. And inside that is where all the artifacts get extracted to. So here's your inventory and your roles. So if you had any issue with a particular box, you could go straight to it and you could determine the location. So we're using the default Octopus location, but you can obviously put it wherever you want. You could extract it to a custom centralized place for all your configs. You could even run it from a file share if you wanted. So that's it. That's all the material that I have. Any questions, or I can talk about the Docker stuff. But so yeah, just a quick note. If you're interested in running through all these demos or seeing how it's all set up, I have it all in imports with this, and so all you need is a Docker host, and the instructions to do all that are in the README of this repo. So you would install Docker on your Windows 10 host or whatever, install Docker Compose, and you would clone it, run these couple commands here, and then if you ran this, it would open up your Octopus UI with a username and password, and then you would be able to replicate everything that I just shown you. So thank you for your time.
Thank you, Josh. If anybody hasn't checked out Josh's blog, I'd recommend it. He's got a new blog article called Detaching from Distraction, and I thought it was really good.
Oh, it's always going to switch me. Thanks for the reminder of the About Me slide. So I try not to do, like everybody says, don't introduce yourself first. So I'm trying to take that to heart, and we'll do it at the very end. So like I said, my blog's stephanie.io, just my last name. You can find the demo presentations there, and I have a ton of stuff on GitHub. And you can also tweet at me at Josh Duffney.
Okay, I just wanted to thank you again, Josh, and I actually enjoyed that. I honestly didn't know what Octopus Deploy was, and I do think it's really neat how they have their terminology, like tentacles and stuff like that.
Yeah, it's the end-all be-all of our orchestration tool. So, I mean, you can use anything else. Octopus is a great product and a great tool, and I recommend it. But it doesn't mean that you can't use any other tools for the type of framework that we've laid down with the Invoke DSC, or even create your own. So I'm glad everybody enjoyed it. So
yeah, very good. Thank you, Josh.
Appreciate your time. It was a pleasure being on.